Welcome back to our course, as we have now had the first chance for motion physics that is all about energy and giving pushes, pulls to create bodies to start moving faster in different directions. That's what we talked about in the first 2 weeks. We're going to make a transition into talking about light, sound, electric kinds of systems, and they're going to be governed a lot by waves. Waves, obviously, you are from Southern California and so have an interest there. There are kind of a couple of types of waves that we might talk about. The ocean waves, which are quite typical, and we would call them transverse. They're going to have this up and down sort of motion, but there's also waves that come as waves of crashing pressure. The slinky is probably the best kind of describer of these. You can see, if I want to talk about transverse waves, just like the ocean, there may be times when they're moving like this. Now the particles, as the wave comes through, are just, the wave is just a transfer of energy. It really doesn't move particles. The slinky doesn't move. This transverse wave, though, is allowing energy to pass through from my hand over to this hand. And when it does, the particles move up and down. They're perpendicular to that movement of the wave. That is why it's called a transverse wave. The particles move perpendicular to the direction of the wave. In sound we're going to see is going to be like this material. I'm going to turn it just a little bit so you can see it a little better. You can see that there are some waves sending a pressure wave downwards down this length. I've got another slinky set up so that it's just hanging. You can see these two phenomena maybe even better. And so let me turn that for you. You'll get a chance to see. I want to shoot it just a little bit of an angle so that you can get a better feeling for this. But here's the same slinky that's suspended. And if we talk about transverse waves, we can see that the wave is moving back and forth as it travels down. What's interesting is it hits the other side. You may notice as that hits that side, it'll come back on the other side of the slinky. Now we can also send a pulse. That if I bring these together, I can send a pulse down the length of the slinky, and that's the longitudinal wave.